Okay, continuing on in the section 5.3, now we're going to show ourselves how to divide monomials. So I'm going to work out several problems, and the instructions for these may say divide, or of course the word simplify. So suppose I have the monomial 25x to the fifth, and I'm going to divide that by 5x to the fourth. Well, to divide monomials, it's usually nice to kind of separate like bases apart. So the coefficients I'm going to separate and report it as 25 divided by 5 times x to the fifth divided by x to the fourth. Now 25 divided by 5 reduces down to 5, and when you divide like bases, remember the rule for exponents says we keep the base the same, and we subtract the exponents. Specifically, we take the numerator exponent, subtract off the denominator exponent. So what we're going to have is 5x to the first power, or just 5x. That would be the quotient of having divided these two monomials. Let's look at another one. 32a to the fifth, b to the sixth. Suppose we want to take that monomial and try to divide it by 8a b to the fifth. Again, splitting up like bases is helpful. So I'm going to put the 32 over the 8 times the a to the fifth. I'll place over a to the first. This is a to the first. Times b to the sixth. I will place over b to the fifth. Now 32 divided by 8 reduces down to 4. A to the fifth divided by a to the first is a to the 5 subtract 1 power, or a to the fourth. B to the sixth divided by b to the fifth is b to the 6 minus 5 power, or b to the first power. And ladies and gentlemen, there's your answer. How about 5x to the fifth, y to the fourth, z? Again, if you have z's, make sure you put slashes through them. Divided by the monomial 30x cubed, yz squared. Again, let's split up like bases. Put 5 over 30 times x to the fifth divided by x cubed times y to the fourth divided by y times z divided by z squared. Okay, 5 over 30 reduces down to 1/6 times x to the fifth divided by x cubed would be x to the 5 subtract 3 power, or x to the second power, times y to the fourth divided by y to the first power is going to be y to the 4 subtract 1 power, or y to the third power, times z divided by z squared is really z to the first power divided by z to the second power, which is really z to the 1 subtract 2 power. 1 subtract 2 is -1, so this is going to be multiplied by z to the -1 power. Now, ladies and gentlemen, as mentioned earlier, we don't like to leave final answers with negative exponents in them, so we're going to have to tidy this up here. So therefore, we're going to report this as 1/6 times x to the second power times y to the third power times, now z to the -1 power is understood to sit over 1. To do away with the negative sign on the exponent, we're going to have to take the base of z and flip it or reciprocate it down into the denominator, in which case we report z to the -1 power as 1 over z to the +1 power. Now to clean this up, x squared and y to the third sit over 1 understood. Our final answer is going to be, as we multiply our numerators together, x squared y cubed, and our denominators multiplied together will be 6 times z, or 6z, and that would be your final answer for that problem there. Now for the grand finale of dividing monomials, let's try this one here. Actually, I'm going to use a different piece of paper. This one requires a little bit more space. Let's take the monomial 4x squared y cubed, which is to be cubed, And we're going to divide that by 2x cubed y squared to the fourth power. Okay. So the instructions will say divide or simplify here. To do so, we have to address the outermost exponents in the numerator and denominator first. So this numerator monomial has to be cubed, which means every factor of the monomial has to be raised to the third power. So therefore, we'll have 4 raised to the third power times x squared that has to be raised to the third power times y cubed that has to be raised to the third power. And this will all sit over 2 to the fourth power, x cubed to the fourth power, y squared to the fourth power. Now, 4 cubed is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. When you raise a power to a power, you keep the base the same and multiply the exponent. So x squared cubed is x to the 2 times 3 power, or x to the 6th. Y cubed is y to the 3 times 3 power, or y to the 9th. And this is all going to sit over 2 to the fourth power. Now, 2 to the fourth power is 2 times 2 times 2 times 2, or 2 times itself 4 times. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. X cubed to the fourth power is x to the 3 times 4 power, or x to the 12th power. Y squared to the fourth power is y to the 2 times 4 power, y to the 8th power. Now we're back to where we came from. Let's now split this up, putting like bases kind of like over each other. (64) divided by 16, believe it or not, 16 does divide into 64 4 times. So that reduces down to 4. X to the 6 divided by x to the 12th power is x to the 6 subtract 12 power. And 6 subtract 12 is negative 6, so that'll be x to the negative 6th times y to the 9th divided by y to the 8th power is y to the 9 subtract 8 power, which is y to the first power. And again, ladies and gentlemen, we don't like to leave any negative exponents appearing in our final answers, so we're going to have to do away with this negative exponent of negative 6. Understanding that the x to the negative 6 sits over 1, we flip the x down into the denominator. And so we're going to have 4 times 1 over x to the positive 6th power times y. Both the 4 and the y are understood to be over 1s. So our final answer, as we multiply our numerators together, will be 4y sitting over 1 times x to the 6 times 1, which is x to the 6th. That's your final answer to that problem. That concludes this video. I will wrap up section 5.3 talking about scientific notation and operations surrounding those constructs. So stay tuned.